Hello, class receiving students and teachers. You may sit down. Teachers, once again, we are still on the same strand, same substrand, and same outcome. Now, students in the receiving schools and the class, you were told in the previous lesson of the next lesson activity, which is on transportation and deposition. Now, I'd like the class and the receiving students, if you can tell me what transportation is. Now, this transportation is not to do with vehicles that carry us from one place to another. This is to do with, at the moment we are on rocks, talking about rocks. And previous lesson, we had a look at weathering and erosion. Now, transportation has to do with weathering and erosion. So if I can have someone from the class to tell us what you think of transportation. Messi, if you can tell us what you think of transportation.
How the main agents of erosion transport rocks from one place to another.
Okay, good, thank you. So when we come to that part of our lesson, at least you should know what it's all about. Now, our previous lesson was on weathering and erosion, quarrying. What is weathering?
Weathering is a process by which rocks are broken down.
Good, thank you. Aloysia, there are two types of weathering. What are they? Receiving students, you can tell your teacher.
Physical and chemical.
Physical and chemical weathering. Chemical weathering, William, if you can tell us what chemical weathering is, receiving students, tell your teacher.
Minerals in the rocks react with water and air, causes rocks to crumble.
Good, thank you. Now weathering also goes together with erosion. Class and the receiving students, if you can tell me what erosion is. What is erosion? Let's have Adrian to tell us.
Erosion is the movement of soil and other weather materials from one place to another.
Very good, thank you. Now we had earlier in the lesson, Messi telling us what transportation is. And transportation in rocks is not talking about what I just said earlier about, it's a bit like us moving from one place to another using vehicles. That's our means of traveling from one place to another. Now, we come to our topic which says transportation and deposition. Just like weathering and erosion, transportation and deposition, they go together. Now, if you have a look at the screen, we have two pictures. There are two there. One at the bottom shows us sea, and one on top shows us river. Now, river shows us that is another means of transportation of weathered materials. And deposition shows us where these weathered materials, when they are transported by river, where they are dumped or left. Now let's see what transportation is. Now it is movement of weathered materials by rivers where they enter the swamps, lakes, and the sea. Now, river is one of the means of transportation of weeded materials, and besides rivers, we also have other transportation agents, just like we had a look at the previous lesson on erosion agents. We also have other means where weeded materials are transported. And one of them is landslide. Landslide is where, when landslide occurs, the rocks that are broken down from the side of a hill or mountain slide down into the rivers, where they are carried by the rivers and dumped into the seas, lakes, or swamps. Another means of transportation is wind. Wind is another means of transportation. Another is ice, glaciers. We had a look at that also in the previous lesson on erosion. Glaciers also, or ice, also helps in transporting weeded materials. Now let's see what deposition is. Weeded materials settle to the bottom of the lakes, swamps, and the sea. And that is what it's meant by deposition, or weeded materials are deposited or dumped into the lakes, swamps, and the sea. Now, sometimes these weeded materials, they often collect or come together at the mouths of rivers. Students in the receiving schools, especially those who live along the coast, if you have big rivers, you will see at the mouth of the rivers where these weeded materials are deposited or dumped by rivers, they build up what is known as delta or swampy plains. So if you have a big river at your place are receiving students, those who live along the coast, you may have a swampy plain just like that we have on the screen. Now, our activity for this lesson. Firstly, we have to predict what will happen when the sediment or the mixture reaches the tray. We will be doing an experiment where we will be using trays, and students in the receiving schools, you may be using some old bowls or whatever that you have available. And you also have to give your reasons for the prediction you made. Now, I'd like you to discuss quickly within your groups, and predict what you think will happen when the sediment mixture that we will be making in our activity, what will happen when it reaches the tray that you will be using. Okay, let's have from Shane and his friends what their prediction is. What is your prediction? Thank you. We have Jennifer.
We think that the solid materials, the rocks are gonna drop first down to the bowl, and then the the gravel, and then sand.
Now you said you predict that rocks will settle first and then you have the gravel and the sand. Can you give us a reason why you say that, why you have predicted that?
Because the rocks are heavy.
Because the rocks are heavy. Thank you. Once we do the experiment, then we'll see your predictions, whether you have predicted well. Now, I'd like the runners to come and pick up your materials. A runner from each group. You get one for you and your friends there, and that one goes to the back group there, over there. Now I'd like the class to check to see that you have a tray with a mixture of gravel, sand, soil, and some solid materials. You should also have a beaker, a stirring rod, and a piece of cardboard. You should also have a piece of cardboard, a rag, and newspaper with you. Please, class, check to see that you have all that with you. Now, class and the receiving students, I'd like us to have a look at the experiment steps that we have. We'll go through the experiment steps quickly, and after that, the experiment steps are there on the chart in front of you. So you have a look at it and try to follow the instructions and do as required. Now the first one, it says you are to put sand, mud, soil, and pieces of solid materials on a newspaper on your desk and mix them together. Then you place the mixed material in a tin, and that is for receiving classes, but model class you have beakers to use. Next, you pour some water in and stir it well. Now, the mixture that you have must be thick. Put one end of the cardboard in the tray or container. The cardboard must be folded into half. You have to fold the cardboard into half. Now, you are to pour the mixture through the cardboard. The mixture should run down the cardboard and into the tray. Then while that is happening, you observe very closely to see what happens when that mixture is reaching the tray. And you record your findings by answering the questions. Now, these are our questions. I'd like the class and the receiving students to take note of these questions. A, it says, does the speed of the mixture change when it enters the tray? If you say no, then you have to give your reason why. C, what happens to the solid materials as it enters the tray? D, which particles settle first, the largest or the smallest. If you say largest, you have to have your reason why. If you say smallest, you also have to have your reason why. E and F, you write your answers for what transportation and deposition is. The class and the receiving students, this is how you should set up the experiment. You have a tray, receiving students. If you don't have tray, then probably you should have some old bowls to use. You have a cardboard that is folded, a folded cardboard. And you have silt and water is all those sand, gravel, and solid materials that when you mix them, and don't forget that mixture has to be thick mixture. Don't put too much water and you find that your mixture is not thick. Now, I want the class and the receiving students to listen as I go through what we are actually doing in this experiment. Now, our tray or the bowl that you are using, receiving students, it represents a lake or sea or a swamp. The folded cardboard represents the river that is transporting all those weeded materials. And the mixture that you have in the beaker or tin is the weeded materials. So we have the weeded materials in the tin or beaker, and they're transported down the river, which is the cardboard, and they are deposited into the lake, sea, or river, which is the tray or bowl that we have. So that is how you should set up your experiment, your apparatus that you are going to use, and you should start. The steps are here. See that and follow receiving students if you are doing your experiment. No, that's enough. Your bowl is too small. Mix that one up. You need some more. No, in there. Sorry, for your bag. You have to have some more.
Thank you.
Okay, mix them well. You should be going on to the next step. You see all the steps are there. You are sharing with the table there, so check with them.
no water.
You share with, yeah, okay, thank you. Just stick this one at the side of your tray. Stick this one at the side of your tray. This one at the side of your tray. Stick this one at the side of your tray. That's your tray. Yeah. Make sure you don't put too much. You have to stir it well to get it mixed up. Poppy, you will have to try your best to get all those weeded materials in there to come down. So what are you going to do now to get that one down? You'll have to mix it again. Okay, you can mix it again, put some water to get all that into the tray. Make sure when you are mixing it and it's up, you get it down. Because once it settles, it's hard for you to get it inside when it's in there. While you are mixing it, Shane, while you're mixing it and it's all up and none is settled, that's the time you quickly. When everything is up. When everything, once you stir it, you see they are all up above. There's none at the bottom. So once it's like that, that's where you pour it and it all goes down. Okay, so while it's like that, you get it down. Okay, go on. Okay, one more to get that bottom down. Yep. While I'm doing it, pour it. Try again to get that one down. What's happening when it's going down there, you check it. You have to try your best to get all these weeded materials down together with the sand and what you have there. Already working good, yes. Yeah. These people already did it well. They were able to get all of them. Oh, get all working good. That's okay. You're going to make your water overflow. When you can't push it down.
That's what some people did. They put the water out, they got the streamer and they started pushing the stuff.
Okay. While you're stirring it up like that, you quickly get it down. You see what, like these people did, that's all down. That's all done. See? Okay, leave it there and you can do that one there quickly. careful. Get your rag. You should be answering your questions now. Okay, here, sing. While you are, wait, while you are staring, you start doing that. So, put your rag there under the one, rag over. Okay, see. While you are staring, you keep on doing that circle. But you others, you must see how it's reaching that tray. Whether it's slow or fast, let's just get it done. Sorry, Helen. We just get this one done. Okay, that's enough. Thank you. Put this one back in there. Now, because you have a lot of water, we have to pour some out so you see how it's settled to help you to answer your questions. You were supposed to, this newspaper was for you to spread it, see? And then you try to see how it's settled. Okay, you try to see how it's settled. But when it was entering the tray, it's talking about the speed now. How was it? You discuss about it quickly. The speed of the water. The mixture is actually your river, that's your sediments that's flowing through into the what? Let me see what you have for your. You haven't done your A yet?
Yeah.
That's how you observe it when you were pouring it in and then it ran in. Was it slow once it entered the tray? Was it slow in entering the tray or it was fast? So that's what it's talking about, the speed. You should be discussing it so you all have the same answer. The water together with the materials that ran down. Answering questions. Teachers in the receiving schools, the experiments that the students do, you have to put those experiments away in a safe place. And during our lesson 92, we will be checking on the experiments the students have done to have a closer look to see what actually happened to the mixture that the students have done in this lesson. Now, we will be having your friends in the model class to just give me the answers to their findings of the experiment that they have done for this lesson. Our first question related to the experiment, it says, does the speed of the mixture change when it enters the tray? That is just like a river running down, carrying all the weeded materials, and when it enters the lake or the sea, how does it enter the lake or the seas? The speed of it, is it fast, is it slow, or how is it? So here it says, does the speed of the mixture change when it enters the tray? Let's have group 1. They will give us the answer to this question. Thank you, Carol.
It slows down.
Slow
yeah,
down.
it changes. The speed changes.
Okay, you say slow down. That means no. So what's your reason?
So it's yes.
Yes, okay. If you can tell us your reason, whether it's yes or no. You said yes, you could have a reason for saying yes.
Just, when it comes down, it moves fast, then it goes slow.
Okay, good, thank you. Our second question, see, it says, what happens to the solid materials as it enters the tray? Railing. Receiving students, you can tell your teacher. What happens to the solid materials as it enters the tray?
They all settle to the bottom of the lake.
Okay, good. Bottom of the lake or bottom of the tray. Now, the next question says, which particles settle first, the largest or the smallest? If you say largest, then you give a reason why. If you say smallest, you have to give a reason too as well. Okay, let's have that from William and his friends.
Largest. The largest.
Your reason?
Because they were all heavy, and when they were poured, because they were all heavy.
Okay, good, because they're heavy, so they reach the bottom of the tray before the others. What is transportation? Regina?
Movements of weather materials by rivers where they enter the swamps, lakes, and the sea.
Okay, good, thank you. Shane, what is deposition?
Weathered materials settle to the bottom of the lakes, swamps, and seas.
Very good, thank you. Now I'd like us to look back to our predictions, where we had a group, Jennifer told us from her group, the predictions was rocks first, they have gravel, then sand. And the reason was, they said because rocks first, they gave the reason as rocks are heavy. So we had a group that gave us the answer, the largest settle first. Because they are large, heavy, they settle to the bottom, and then we have the lighter ones that settle on top of it. Class, I'd like the runner from every group to take your samples. There is a place provided at the back. I'd like you to put those over there quickly so we can go through the summary for our lesson. The next one. Now we just go through quickly with the experiment that we have just done, which is on transportation and deposition. The experiment we have just done, the diagram we have here, we have weathered materials and rocks, which are called sediments. These sediments are transported by rivers. River is one of the main means of transportation of weathered materials. Now, these weathered materials are transported by rivers down to lakes, swamps, and the sea. Once they reach the rivers, lakes, and the swamps, they are dumped or deposited. And as we have just seen in the experiment, the larger particles or larger weathered materials, they settle to the bottom first. Then we have the smaller ones, the settle on top of that. And those settled sediments, they tend to another form of rocks. So we will be having a look at that in the next lesson. Now our summary, one, it says weeded rocks with other materials carried off by the rivers and deposited into the sea, lakes and swamps are called sediments. The next summary point says the river water slows down as it reaches the swamps, lakes, and the sea. There the sand, gravel, and pebbles are small rocks, settle as sediments. Our last summary point, the largest material settle at the bottom of the lakes, swamps, and the sea before the smallest. Let's have Anna to give us our key phrase for this lesson.
Settlements.
Sediments, thank you. Let's see what I have. Transporting and depositing sediments or weeded materials. Our next lesson is going to be on sedimentation and materials needed. Class and the receiving students, you are to help your teachers and provide the materials that are listed there: dried mud, gravel, sand, and round glass jars. And these round glass jars must have lids. Your teachers will try to provide glue, PVA glue, plastic cups, and water. It's easy to get. And with that, thank you, class and receiving students, for your participation.